I'm eating crow. There's a reason that's a bad thing. Rebuttal apology video. No, I'm not gonna start fucking crying. See, the space Tether Experiment keeps getting mixed up with the space Tether Incident. That, and it was 1996. I remembered wrong. In part 1, I made mention of how my manic mind works. I'm thinking much clearer now. Thanks for asking. I was way off base. Between remembering things wrong, getting the two stories wrong. Hello and welcome to Quiet Dignity and Grace. Like, hate, share, scribe, comment if you need to. Notification bell because of reasons. Links for things are down in the linky spot, including a link to the actual experiment report. And boy, did I get the story wrong. It'll help you get past all this garbage, all this UFO crap. That's what I was after. Couldn't find it. Okay, it was an experiment between the US and Italy. A large spherical satellite be deployed from the US space shuttle at the end of a conducting cable, tether, 20 kilometers, 12.5 miles long. The idea was to let the shuttle drag the tether across the Earth's magnetic field, producing one part of a dynamo circuit. The return current from the shuttle to the payload would flow in the Earth's ionosphere, which also conducted electricity, even though not as well as the wire. One purpose of such a setup might be to produce electrical power or electric power, generating current to run equipment aboard the shuttle. That electric comes at a price. See, this is where they lose me. That electricity comes at a price. It's taken away from the kinetic energy of the shuttle, since the magnetic force on the tether opposes the motion. Say you're heading that way. Whatever. Opposes the motion and slows it down. But in principle, it should be possible to reverse the process. A future space station could use solar cells to produce an electric current, which you already are with the stinking thing. Produce an electric current, which would be pumped into the tether in the opposite direction so that the magnetic force would boost the orbital motion and would raise the orbit to a higher altitude. They want to use tethers and use the Earth's magnetic field against itself is what they're trying to do. Is the second principle they were trying to accomplish. The first attempt at the Tether experiment ended prematurely when problems arose with the deployment mechanism, but the one on February 25th, 1996 began as planned, unrolling mile after mile of tether, while the observed dynamo current grew at the predicted rate. The deployment was almost complete when the unexpected happened. The tether suddenly broke. See, I thought, well, you know what I thought if you watch part 1. Tether suddenly broke, and its end whipped away into space. Wiggle, 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 wiggle. Snap. And it wasn't deployed from the arm either. My bad on that one. But there you go. And now it's a glowworm. Whipped away into space in great wavy wiggles. Got her. Filled this out. The satellite payload The satellite payload at the far end of the tether remained linked by radio and was tracked for a while, but the tether experiment itself was over. It took a considerable amount of detective work to figure out what had happened. It wasn't UFOs. Back on Earth, the frayed end of the tether aboard the shuttle was examined. Pieces of the cable were tested in a vacuum chamber. I'm not going to illustrate this. The nature of the break suggested it was not caused by excessive tension, because nothing weighs anything out there, but rather, well, mass, I guess, okay, but rather than an electric current had melted the tether. I thought it got too hot. I thought they deliberately jettisoned it. The electric conductor of the tether was a copper braid wound around a nylon string. It was encased in Teflon-like insulation with the outer cover of Kevlar. All this inside a nylon sheath. The culprit turned out to be the innermost core, made of a porous material which, during its manufacture, trapped many bubbles of air at atmospheric pressure. Oh, that can't be good. Later vacuum chamber experiments suggested that the unwinding of the reel uncovered pinholes in the insulation that in itself would not have caused a major problem because the ionosphere around the tether under normal circumstance was too rarefied to divert much of the current. However, the air trapped in the insulation changed that. As it bubbled out of the pinholes, the high voltage electric pressure of the nearby tether, about 3,500 volts, converted it into a plasma in a way similar to the ignition of a fluorescent tube. But it was converted into a plasma, a relatively dense one, and therefore much better conductor of electricity. So yeah, they made a plasma cutter. The instruments aboard the tether satellite showed that this plasma diverted through the pinhole about 1 amp, a current comparable to that of 100-watt bulb, but at 3,500 volts, to the metal of the shuttle, and from there to the ionospheric return circuit. That current was enough to melt the cable. As the broken end whipped away from the shuttle, the plasma established electric contact with the ionosphere directly. That would be this shit. Because fire works differently in space. The satellite on the distant end monitored the current. After about half a minute, it stopped. Then it reignited and flowed again for about another half minute, stopping for good when presumably all the trapped air was gone. Because of the unexpected break, the tether experiment at the time was widely viewed by the press as an expensive failure. True, the planned operation at full deployment for several hours could not take place, nor could the tether and its satellite be retrieved, which was to have demonstrated the feasibility of deployable tethers. However, many of the scientific experiments had already begun during deployment and yielded good data. And the break itself, although unfortunate, added an unscheduled experiment to the mission, one which highlighted the risks and complexities of operating scientific equipment in space. Okay, that's what happened. Cleared that up. But using that, just on the energy alone that's created by being in the ionosphere, you could still do that. Get a length of copper, make yourself a battery. Get rid of these things. It would still work. Lightning in a bottle, so to speak. Instead of using a copper weave and all that insulation and everything, that's your insulation. Liquid and space. The science is there. I just wish they'd do something with it. Just a quick aside. That's the first time I did copy on my channel. How'd I do? I haven't looked at any of the math. I haven't done nothing. That's the first time I had read that. Why would I lie? You're not paying me. Let's work with the knowns, shall we? 20 kilometer long. I'll be using standard imperial at 12.5 miles. They mentioned it repeatedly, 3,500 volts. 5,280 feet per mile and 2,640 miles for the half. I'm left with one question though, because it does not say how much of the tether was deployed. All it says is the overall, it gives the overall length, 12.5 miles. Where they got the 3,500 volts, were they measuring it back on the shuttle in the winch? Now, were they monitoring it from inside that, or were they taking readings off of the line as you would, inspecting a house or some shit? Put a magnet over a wire and see how much it's conducting. Or would that be redundant, using a magnet and a magnetic field to check the... Yeah. So I have to assume, and that's why I'm doing a rebuttal video, because I fucking assumed a bunch of shit, that they're taking the reading from the overall length back in the shuttle. There's nobody out there on a jetpack checking the line, so must not have been a union job. All right. 12 miles. Is 63,360 feet. Plus another 2,640. Comes out to an even 66,000 feet. Cool. Now, divide that by the only metric given. Not metric, the measurement. The only measurement given. That metric. Not that metric, that metric. By 3,500 volts. And we come up with 18.85 volts per linear foot. 66,000 feet divided by 3,500 volts comes out to 18.857 volts per linear foot. And that's using their metric. So a battery is possible. That would replace a whole bunch of extra you guys keep taking up there. I'm just wondering why they didn't start this shit in the 50s. And I had already thought, before I even read this, and it said like converted into a plasma in a way similar to that of a fluorescent tube. I was already thinking, make them universal. You got your two prongs on one end of the canister. Yeah, you got your positive and negative on top of your canister. One port, and they're universal. You got 18 volts for that 1 foot. Put a loop in it. Then you got 36 volts in an interchangeable canister. Self-contained, cooled, regulated, vents all of that extra heat right into space. This is plausible. I want 3%. It's my idea. I want 3%. Seriously, why didn't they come up with this shit in the 50s? And you can turn it off. Maybe. No, you just jettison another fucking piece of wire out there. Hope it don't clip into a fucking solar panel. My idea is sound. This'll work. Hell, you can even save money. Make it a 12 volt. Yeah, hell yeah. 6, 12, 18s, and 24s. Base 6 math, unfortunately. Beats the shit out of base 8 math. I apologize for misinforming you, because I didn't check my sources. I didn't check any damn sources. I just went top of my head. Oh, and as for coolant, you've been using it for well over 100 years. Cooking oil. High-tech shit. This has been Quiet Dignity and Grace. Like, hate, share, scribe, comment if you need to. Links for things, including that Goddard report. Yeah, I thank you so much for watching. I don't get it. Why haven't they been doing this? Or have they? Ooh!